Good day, learners! Our lesson for today is all about solving radical equations. We are going to find the value or values of the variable that would make the equation true. First, we have to define what a radical equation is. A radical equation is an equation that contains a variable in the radicand. In solving radical equation, we have to apply our knowledge on the different laws of exponents as well as some algebraic principles. The first basic step in solving radical equation is to isolate the radical term first by applying the appropriate properties of equality. Next, combine similar terms whenever possible. Then, raise both sides of the equation to a power to remove the radical. What does it mean? If the index is 2, then raise both sides of the equation by 2. If the index is 3 or cube root, then raise both sides of the equation by 3 or get the cube of both sides of the equation. When you have solved already the radical equation, make sure to do the checking. It should produce a true statement when a value is substituted back to the original equation. If not, then we consider that value as an extraneous root. An extraneous root is a number obtained in solving an equation. It may seem right, but when you substitute it to the original equation, it produces a false statement. This time, we are going to solve a radical equation. Again, when we are asked to solve a radical equation, we are actually looking for the value or values of x that would make this equation true. So, remember the first step, we have to isolate the radical. So this one, we are going to transpose negative 3 to the other side and leave square root of x to the left side. So square root of x is equal to 5, negative 3 transposed to the other side is positive 3. So actually what we used here is the addition property of equality. We are adding positive 3 on both sides of the equation. So negative 3 plus 3 is 0. Then 5 plus 3 is this one. Okay? So square root of x equals 8. Because the next step is combining like terms. At this point, we are going to combine the constants. So we have now square root of x, which is equal to 8. Since the index is 2, we are going to raise both sides by 2. Because it is understood if it is square root, then the index here is 2. If it is cube root, then we are going to raise both sides by 3. Okay? So, what is left here is x equals 8 squared is 64. You might wonder why we canceled the radical and the exponent. Actually, square root of x is actually x raised to the power of 1/2. Actually, the radical, when you transform it, it is a base to raised to a fractional exponent. So, here, when we say square root of x raised to the power of 2, that is actually x raised to the power of 1/2 and raised again to the power of 2. So, here, x, remember, power of a power, 2 times 1 is 2, divided by 2 is 1. So, what is left is just x. That is what happened here. So, x is equal to 64. Now, we are not going to conclude yet that this is the solution to this equation. Why? Because it is really a must that we have to do the checking. How are we going to do that? We are going to substitute the value of our x to this term. If the resulting equation would make a true statement, then x is really equal to 64. So going back to the original equation, square root of x minus 3 is equal to 5. Since the value of x is 64, so that would be square root of 64 minus 3 is equal to 5. Square root of 64 is 8. Why? Because 8 times 8 is 64. That is the number under the radical symbol. Minus 3 equals 5. This part, we are not yet sure if that is really equal to 5. So that's why I put question mark here and this one. 8 minus 3 is 5, which is really equal to 5. That's why I put a check mark here. So, the resulting equation is true. It produces a true statement. Therefore, the value of our x is really equal to 64. This value makes the statement or makes this radical equation true.